The next section in our prerequisites unit is exponents in scientific notation. First of all, a few definitions. Exponential form is when you have repeated multiplication. So remember, when you're looking at a power, the base is kind of the bottom number, and the exponent is the power, which represents how many times you multiply the base by itself. We have several properties of exponents. Hopefully you are familiar with most, if not all of these. The first one is that when you multiply powers together, you add those exponents. When you divide powers, you subtract the exponents. A negative power means you flip the power to the denominator. Let me go through why this one works. For example, if you have a squared divided by a to the fifth, working this out the long way, a squared means a times a to the fifth means a times itself 5 times. And by property of division, we can cancel out 2 of those a's. A divided by a is 1, so we have a 1 in the numerator, and a times a times a is a cubed. The other way to look at this is using that division rule where you subtract the exponents. 2 minus 5 is negative 3. So the reason that you flip the exponent is because those variables are left in the denominator after you cancel. A to the 0 power is 1, and I could prove this in a very similar fashion to what I just did. If you have a squared over a squared, everything cancels, leaving you with 1, and 2 minus 2 is 0, or a to the 0 power. Number 5 is an example of distributive property, as well as number 7. And number 6 is the power to a power rule, where you multiply those exponents. Be careful, a lot of students tend to confuse the rules for number 1 and 6, and they try and add when they're supposed to multiply, and vice versa. Our essential question for today is, why do the properties of exponents work? I ran through a couple of proofs for you, but I want you to think about the reasons why they work, and that will help you remember the rules and be able to apply them. Off to the right, I have some general steps for working with simplifying exponents. You don't always have to do them in this order. Sometimes you can't do them in this order. You need to follow order of operations. So when you look at an expression, think about what can you legally do first when you're simplifying. In this case, when we have something times something, you can go ahead and multiply those coefficients together. 3 times 4 gives us 12. And then a times a gives us a squared, adding those powers together. And then b to the 4th times b to the negative 3, adding those powers together, gives us b to the 1st power. Looking at this a different way, simplifying that negative exponent first, which is an option, we would leave 3ab to the 4th alone. We would leave 4a alone because only the b has a negative exponent. So only the b would move to the denominator, and that 3 would become positive. Simplifying, we still have that 3 times 4 in the numerator. We still have a times a in the numerator. And then we would use our division rule and subtract those powers. 4 minus 3 is 1. We'd be left with 1b again. Our next example, we have the power of a power rule. A lot of students try and treat a base, when it's a number, like an exponent, and they'll end up multiplying 2 times 3 instead of raising 2 to the 3rd power. So one way to combat that would be to just distribute that power first to each of the terms and then simplify. 2 cubed, 2 times 2 times 2 is 8. We have x cubed, and the power of the power rule, multiply that 2 and 3 together, and you get y to the 6th. This whole expression is being raised to the 0 power, and the rule for raising something to the 0 power is that it turns into 1. So we have 3a times 1, or just 3a. Here again, we're going to distribute that power on the outside, so we have 5 squared. We have x to the negative 3 squared, and we have y squared. Again, we could have moved that x to the negative 3 first. That order doesn't matter. You can do it before or after. 5 squared is 25. Multiplying those exponents together, we get x to the negative 6 over y squared. And all of your expressions should be simplified with no negative exponents. So we're going to flip that x to the denominator, make that 6 positive, and multiply it by the y squared that is already there. On this one, since we have no outside power, I'm going to start by flipping those negative exponents. 12 does not have a negative exponent. A cubed does not have a negative exponent, but that b to the negative 4th does, so I'm moving that to the denominator and making that exponent positive. 4 does not have a negative exponent. A to the negative 2 does, so I'm flipping that to the numerator and giving it a positive exponent. And then that b in the denominator does not have a negative exponent. Simplifying, I have 12 divided by 4, which is 3. A cubed times a squared is a to the 5th. Add those powers together. And b to the 4th times b is b to the 5th, adding those powers together again. On this example, I am going to make a mistake. It's a common mistake that I see a lot of students make. I want you to catch my mistake and correct it. First of all, I'm going to start by distributing that negative 2 to each piece inside the parentheses. Three to the negative 2 power is negative 9. Negative 3 times negative 2 is positive 6. And that y to the negative 2 will move to the numerator, and the negative 2 will become positive 2. Again, I made an error in this one. Please find my mistake and correct it. If you can't find it, we will work in our groups tomorrow in class and find it together.